Let us now take a problem from the AP exam. Here we have the integral of t over the square root of 2t squared minus 1. Again, let us first start by noticing the inner function. The inner function here is 2t squared minus 1. So let u is equal to 2t squared minus 1. Differentiating this, we get that du by dt is equal to 4t, and we get that du is equal to 4t times dt. Looking back at our original integral, we see that we need to substitute t times dt. In order to get t times dt in this, we can divide 4 on both the sides to get du over 4 is equal to t times dt. Substituting this back in the original integral, we get that this equals the integral of 1 over 4 times the square root of u du. Since 1 over 4 is a constant, we can take it outside the integral to rewrite this as 1 over 4 times the integral of 1 over the square root of u du. Now notice that we can rewrite 1 over square root of u in index form as u to the power of negative half. So this is equal to 1 over 4 times this integral of u to the power of minus half du. Using the power rule, we get that the integral of this is equal to u to the power of half times 2 plus c. Simplifying, we can write this as u to the power of half over 2 plus c. Substituting u back, we get that our final answer is the square root of 2t squared minus 1 over 2 plus c. Let us now see how to use substitution in the case of definite integrals. Here we have to evaluate the definite integral from 0 to the cube root of pi of x squared times cos of x cubed. Now, in order to solve this, our first step should be to recognize that our inner function is x cubed. Setting that equal to u, we get u is equal to x cubed. Differentiating both sides, we get du by dx is equal to 3x squared, and du is equal to 3x squared times dx. Now notice here, we want x squared times dx. So we can write this as du over 3 is equal to x squared times dx. Now, in the case of a definite integral, we also need to change the limits of the integral such that it fits u. At x is equal to 0, we see that u is also going to be equal to 0. If x is equal to the cube root of pi, we see that u will be equal to pi. Rewriting this integral, we can write it as the integral from 0 to pi of cos of u over 3 times du. Since 1 over 3 is a constant, we'll just take it outside. We know that the integral of cos of u is sine of u. So rewriting this, we get that 1 over 3 times sine of u from 0 to pi. Now evaluating this, we can write this as 1 over 3 times sine of pi minus 1 over 3 times sine of 0. Note that both sine of pi and sine of 0 are 0. So the answer for this definite integral is 0.